For over a century, the Rete Ovarii, a small, horseshoe-shaped structure tucked away beneath the ovaries, was considered a biological relic, a leftover from fetal development that served no meaningful purpose. Largely absent from medical textbooks and long ignored in discussions of female reproductive anatomy, this structure was dismissed with quiet certainty. But now, in a stunning turn, researchers from the University of Michigan have used cutting-edge imaging and molecular tools to reveal that the Rete Ovarii is anything but obsolete. In fact, it may play a vital role in fertility and ovarian health, opening an entirely new chapter in our understanding of female physiology and reigniting overdue respect for a system long misunderstood and understudied. This breakthrough research, published in eLife, signals a significant shift in how we view reproductive biology. It reaffirms a powerful truth. The female body has never been fully understood, not because it is inherently mysterious, but because the scientific world has too often looked away. The Rete Ovarii, once considered inert, is now shown to be active, dynamic, and deeply integrated into the orchestration of hormonal and cellular communication that supports the development and maintenance of egg-producing follicles. It may, quite literally, help sustain the microenvironment that makes reproduction possible. This discovery is more than just an anatomical correction. It's a reminder of the vast territory of female biology that remains unexplored. The Rete Ovarii was first identified in the 1800s and then, like so many elements of the female reproductive system, effectively erased from active study. What makes this revelation so remarkable is not only what it tells us about one structure, but what it says about decades of missed opportunities to understand, support, and heal female bodies. Researchers found that the Rete Ovarii is composed of three distinct regions: the intraovarian, extraovarian, and connecting segments that appear early in development and remain preserved into adulthood. These regions don't simply sit idle. In newborn mice, the extraovarian portion alone was found to contain thousands of proteins. One of particular interest, IGF-BP2, is associated with the growth factors that help regulate how ovarian follicles mature. In other words, this structure isn't passive. It may be whispering biochemical instructions that guide one of the most delicate and essential processes in the body, the development of eggs that may someday form new life. Even more compelling is the Rete Ovarii's responsiveness to fluid dynamics and hormonal signaling. When scientists injected dye into the structure, they observed active movement of fluid toward the ovary, a clear sign that it functions in communication and transport. On a molecular level, the Rete expresses hormone receptors for estrogen and progesterone, two foundational players in reproductive cycles. This strongly implies that the Rete is listening to the body's hormonal messages and perhaps sending signals back. It acts, as the researchers describe, like a biological antenna, receiving information, decoding it, and coordinating a response to support the ovary's work. The implications of this are enormous. If the Rete Ovarii is truly involved in ovarian homeostasis, maintaining the health, balance, and functionality of the ovary, then it may be a crucial piece of the puzzle in conditions like infertility, polycystic ovarian syndrome, POS, premature ovarian failure, and even menopause. Until now, these conditions have often been viewed and treated symptomatically, without full understanding of the microstructures and signaling pathways involved. This research invites a deeper, more holistic approach that could lead to more precise diagnostics and, eventually, more effective therapies. More broadly, this discovery is a triumph for those advocating for greater investment in women's health research. It's a moment that underscores how much we still don't know, not just about obscure structures like the Rete Ovarii, but about the very systems that define female biology. The historical neglect of the female body in scientific literature has long slowed medical progress, but findings like this challenge that inertia. They prove that when the female reproductive system is studied with the same rigor and curiosity traditionally reserved for male physiology, we uncover powerful truths that can transform healthcare. It's also deeply affirming. For generations, women have lived in bodies that were poorly understood by the very institutions tasked with protecting their health. They've been told their pain was normal, their symptoms hormonal, their anatomy a passive background to male-centric models. But the Rete Ovarii's rediscovery suggests otherwise. It affirms that even the most obscure parts of the female body may carry immense purpose, and that honoring that complexity leads to better outcomes for everyone. The researchers are not stopping here. Their next steps include studying how the Rete Ovarii responds to changing hormone levels and investigating whether its function is altered in disease states. These future insights could lead to breakthroughs in fertility treatments and even early detection of ovarian dysfunction. But the most immediate impact may simply be a recentering of attention, finally giving the female reproductive system the detailed, respectful study it has always deserved. In a world where so much about the female body has been overlooked, the Rete Ovarii's rediscovery is more than a scientific breakthrough. It's a quiet revolution. It's a symbol of what's possible when we question outdated assumptions, shine light into neglected corners, and insist that every part of the body, no matter how small or misunderstood, has value. It is a vivid reminder that progress in women's health doesn't just depend on technology. It depends on listening, on seeing, and on believing that no organ is truly useless until we've taken the time to understand what it's really doing.